right, guys. Now we want to clarify some of the things that I saw with the inverse sign and how we can actually use the unit circle. Okay, so some of you've been having a little trouble picking up evaluating inverse sign through the graphical approach. Okay, so we're going to complement that with looking at the inverse uh, sine and cosine with the unit circle. Now, okay, you're saying, why do I only have the half of the unit circle? Okay, well, it's actually, and we'll show you this momentarily, the right half of the unit circle is where we're going to use to evaluate inverse sine, and the upper half of the unit circle is what we're going to use to evaluate the inverse cosine. Okay, so let's do the right half with the inverse sine. So what we knew that any point on the unit circle uh, had its coordinates. Any point on that unit circle had its coordinates cosine of alpha as the x coordinate and sine of alpha as the y coordinate. So the y coordinate is the sine of alpha, where alpha is this angle of rotation. That's nothing new. Okay, and now, okay, uh, we took and looked at the developing the graph of the inverse sine, and the inverse sine is right here. And we said the inverse sine runs with the range going from negative pi over 2 to positive pi over 2. Okay, that's the range. Okay, so that's the set of y values that we're going to look at when evaluating, okay, inverse sine. So we know that this point down here, which is covered up at 0, -1, which if we went clockwise, we perceive that point down there as, or that angle of rotation as a 3 pi over 2. If we go counterclockwise, which is in the negative direction, this 90-degree sweep is negative pi over 2. Okay? So now, if we are evaluating the inverse sine, okay, remember, the inverse sine is the y value. So if we say the inverse sine of 1/2, then we're taking this y value of 1/2 and we're reading off the corresponding angle, which is going to be, so we're inputting the y and we're reading off the angle, which is of course pi over 6. If we are by the other means looking at the y value of negative 1/2, okay, on the inverse sine, then we're looking at the angle of rotation that forms that, which is going to be this negative pi over 6 angle. So the answer to the inverse sine of negative 1/2 is negative pi over 6. And if we looked on the circle, we know, I mean on the graph, we know that with a negative 1/2, we're going to pick up a negative value, and in fact it's going to be negative pi over uh, 2. Okay. Likewise, if we were asked to evaluate the inverse sine of negative root 3 over 2, so that's a y value assuming the negative 3 over 2 value, okay, on the unit circle, negative, I mean on the graph over here, negative root 2 over 2 is somewhere in about negative 0.85, which is running right down at the bottom here, okay. But on the unit circle, okay, the negative root 3 over 2 is way down here, okay, and the angle of rotation that's sweeping out to that is definitely a negative angle, okay, and we are going to see, of course, that that's going to be on the unit circle, you might label as 5 pi over 3, but it is actually what? Negative pi over 3. Negative pi over 3. So going to our cosine now. Going to our cosine. Um, as we said back here in general, any point was labeled cosine sine. So the x-coordinate is actually the cosine of the angle. The x-coordinate is actually the cosine of the angle. And of course, uh, um, the inverse then, of course, the in the answer to any inverse trig is an angle, alpha, all right? So more specifically, when we're looking at the inverse cosine, okay, we're going to put in an x value, which on the graph, when the x value is positive, it gives us something less than pi over 2. When the x value is positive, it gives us something greater than pi over 2, but less than pi. Since the range of the inverse cosine runs from 0 to pi, then we're going to uh, look at the angle of rotations which run from 0 to pi, okay, which is effectively the upper half of the unit circle, okay, the upper half of the unit circle. So when I ask you, okay, well, let's assume that we have an x value of 1/2. So the x value of 1/2 runs up like this, and we say the angle of rotation that sweeps out that is a angle of pi over 3. So we would say the cosine inverse of 1/2 is pi over 3. Again, if we were doing on the inverse cosine graph, the inverse cosine of, okay, 1/2 would put us up here at something less than pi over 3, pi over 2, specifically pi over 3. Okay, now uh, let's look at this one, the cosine inverse of negative 1/2. Well, negative 1/2 on the graph puts us up here with a remaining inverse cosine value being positive, okay? Um, so let's look at that. So if we're coming out to 1/2 here, negative, we're going to come right to here, okay? This is at 1/2, okay, on the x value. The x value is 1/2. The angle of rotation that forms that sweeps out to that alpha is equal to, okay, is equal to 2 pi over 3. So therefore, the cosine inverse of negative 1/2 is 2 pi over 3. The inverse cosine of anything is always going to be positive, okay, because uh, we're putting in negative x values, but we're retrieving the angles of rotation, which are always going to be positive, okay? And lastly, as a one final one, if I'm asked to evaluate the inverse cosine of negative root 3 over 2, again, from our from our inverse cosine graph, evaluating any value of x will always produce a angle of rotation which is positive, okay? And any negative value going in will always give us some rotation between pi over 2 and pi. Okay, so if we look over here now, and we say, what is the cosine inverse of negative 3 over 2? Well, negative 3 over 2 is again some fractional value, okay, probably about 0.85, 0.85. So we're coming out here. This is the input value of x equals negative root 3 over 2, okay, because clearly it's in the quadrant, second quadrant, where x is negative. And we're asked to find this angle of rotation, um, the terminal side of which has a x coordinate of negative root 3 over 2, and that angle of rotation, as you can see, is pi over 6 short of pi, which of course would be 5 pi over 6. 5 pi over 6. Okay, so hopefully that helps. So when you can use the unit circle when evaluating inverse sine, we're looking at the unit circle where the angles of rotation run between negative pi over 2 and pi over 2, which is to imply the positive side of the right side of the unit circle. And when we're asked to evaluate the inverse cosine, okay, we're looking at angles of rotation running from 0 to pi, which is evaluating or using the unit circle on the upper half of the unit circle. So hopefully that paints a different perspectives and allows for an easier interpretation of what these inverse cosines and sines are asking for. Okay, there you go.